Hi, I'm Kevin Clark, and today we are going to be discussing pH and pOH. pH and pOH are used to measure the acidity or alkalinity of a solution. pH measures the concentration of hydrogen ions in a solution. A solution becomes more acidic when there are more hydrogen ions present. An acidic solution will have a pH less than 7, with 0 being the most acidic. Based on this knowledge, would solution 1 or solution 2 have a lower pH? Solution 1 will have a lower pH because it has more hydrogen ions present, making it more acidic. The pH scale is measured from 0 to 14. A solution with a pH less than 7 is acidic, and a solution with a pH greater than 7 is basic. A solution with a pH of 7 is considered neutral. pOH is the opposite of pH, as it measures the concentration of hydroxide ions in solution. When more hydroxide ions are present, the solution becomes more basic. A basic solution is indicated with a pOH less than 7, with 0 being the most basic. Based on this knowledge, what solution will have a higher pOH? Solution 2 will have a greater pOH because there are less hydroxide ions, making the solution less basic. Two common ways to measure pH are to use a pH strip or a pH meter. To use a pH strip, you dip it into the solution and compare its new color to a key that will allow you to approximate the pH. Another way is to use a pH meter that will sit directly in a solution and read off its pH. There are four main calculations you will need to make regarding pH and pOH. They are calculating the concentration of hydroxide ions, the concentration of hydrogen ions, the pH, and the pOH. As long as you are given one of these four things, you can calculate all of them. This picture represents how to transition between the four. To convert between pH and pOH, use the equation pH plus pOH equals 14. To convert between the concentration of hydrogen ions and the concentration of hydroxide ions, use the formula that says the concentration of hydrogen ions times the concentration of hydroxide ions equals 10 to the negative 14th. If you are given the concentration of an ion, take the negative log of it to find the pH or pOH, depending on the ion. To find the concentration of an ion from pH or pOH, set 10 to the negative pH or pOH. We will do some examples. Our first example asks, what is the concentration of hydrogen ions in a solution with a pOH of 10? The first step is to convert pOH to pH because we are solving for hydrogen ions, which are measured in pH. We use pH plus pOH equals 14 to convert to pH, giving us a pH of 4. Then, to find the concentration of hydrogen ions, we do 10 to the negative pH. This gives us 10 to the negative 4 equals the concentration of hydrogen ions as our final answer. Our second example asks for the pOH of a solution with a hydrogen ion concentration of 0.001. The first step is to convert to pH by taking the negative log of the hydrogen ion concentration. In this case, it is the negative log of 0.001. This gives us a pH of 3. Once we have the pH, we solve for the pOH by using the formula pH plus pOH equals 14. This makes our pOH equal to 11, which is our final answer. Our last example asks for the concentration of hydrogen ions when we are given the hydroxide ion concentration of 10 to the negative 6. To solve for the hydrogen ion concentration, we use the formula that says the concentration of hydroxide ions times the concentration of hydrogen ions is equal to 10 to the negative 14. This gives us a hydrogen ion concentration of 10 to the negative 8th as our final answer. I hope you learned a little bit about the basics of pH and pOH. Thanks for listening.